Connecting to ADB by Oracle Database Actions. Welcome to Database Actions, previously known as Oracle SQL Developer Web. Oracle Database Actions provides a web-based interface with development tools, data tool, administration, and monitoring features, and lets you load or access data from local files, from cloud storage, or from remote databases. Database Actions runs in Oracle REST data services, and access to it is provided through schema-based authentication. To access Database Actions, you must sign in as a database user whose schema has been enabled for Database Actions. In Oracle Autonomous Database databases, the admin user is pre-enabled. To enable another database user's schema, see Enabling User Access to Database Actions. Oracle REST Data Services, ORDS, is the HTTPS web gateway for your Oracle database, which includes features such as Oracle Database Actions, Oracle Apex Access, REST APIs for your data and databases, Oracle Database API for MongoDB, and much more. Container hostname is used to generate self-signed SSL certs to serve HTTPS traffic on port 8443. Database Actions can be accessed using the container host, or simply localhost. To access Database Actions, https://localhost 8443/ords/SQL Developer. Note: for additional databases plugged in using ADB CLI add database command, please use the URL formats https://localhost 8443/ords/database_name/SQL Developer. Open your web browser and type this address and press the Enter. You will probably see a page like this, in which case click the Advanced button. Then click the Continue to Localhost, Unsafe, link. Enter username and password for admin user. Enter admin as username and welcome_12345 as password, then click on Sign In. We are now in the Database Actions web app. This message is about the dark theme. Close it. This interface provides development, data tools, administration, and monitoring features for Oracle Database on-premises and Oracle Database Cloud Services. The SQL worksheet is where most of your work will be performed. Running SQL queries and scripts, creating and browsing objects, loading data, exporting data to CSV or JSON, and so much more. Your day will often start and end in the SQL interface. Click here. We are logged in as the admin user. The admin user is not recommended for regular development tasks, so we need to create a new user. Click the Create User button. Of course, it would be fine if we continued with the admin user. This is for Create User. Fill out the form. This is New User, MKH user. We sign out from the admin user to sign in with the new user, MKH. We signed out from the admin. We enter username and password for the new user, MKH. We are now in the new user panel, MKH. Click here. We are now in the SQL worksheet. This message is about run queries. Close it. This is SQL worksheet for MKH user. The SQL worksheet is a code editor that enables you to enter and execute SQL and PL/SQL statements, and create database objects. To reach the SQL worksheet page, click SQL worksheet in the Database Actions page, or click Selector and select SQL worksheet from the Actions menu in the navigation pane. You can use SQL and PL/SQL statements in the worksheet to create a table, insert data, create and edit a trigger, select data from a table, and save that data to a file. Some other features are syntax highlighting and error detection. The SQL worksheet page consists of the left pane for navigating worksheets and objects, the editor for executing SQL statements, and the output pane for viewing the results. Tables. Tables are the heart of a database. Data is organized into tables. Each table contains several columns. Typically, we need a table for each list of data, such as a list of customers or a list of students or a list of contacts. Each column holds one of the attributes in the list, such as price, zip code, or date of birth. A table is the container and place where data is stored in a database. Let's continue with a simple example, a table for a list of contacts. We will name this table C for contact. This table contains 3 columns, person ID, person name, and person phone. For simplicity, we ignore many of the details like family, address. Do you see the number on the left side of each row? This numeric code is an identifier that identifies each row. With this identifier, a row can be referenced and accessed. That is, we use this identifier to specify and address a row. For example, to specify and address the last row, we say that the row whose identifier is 3. The first column, which contains the IDs, is the primary key of table C and is indicated by a double line. Let's create this table. This command will create our table C. Type it in and click the green button to run. The result of the query is shown in the script output. Table C is created. Click Refresh. Table C in the table list for user MKH. You can see columns of table C. This command will insert one row to table C. This row contains 3 values, 1, Ben, 452,178. Select line 6, then click Run the green button. The result of the run is shown in the script output. 1 row inserted. I repeat this command to add 2 more rows to table C. Choose lines 10 and 12, then click Run, the green button. The result of the run is shown in the script output. A total of 2 new rows were inserted. This statement selects and displays all the rows in Table C. The result of the run is shown in the script output. A total of 3 rows were displayed in the form of a table. The commit statement makes permanent any changes made to the database during the current session. A commit also makes the changes visible to other users. The result of the run is shown in the script output. Commit complete. Everything is permanent.